Hello friends, so welcome back to this next video on the digit recognition, this machine learning model we are studying. In the previous video, we saw what is the MNIST and what does load data do, okay, what it returns, everything we have understood. So there are few other facts which are related to the MNIST, so that I'm going to tell you, and after that we will see the next two lines, what is the meaning of them and what they do. So in today's video, I'm going to tell you rest of the facts related to MNIST, and then we will see how the images are how the images are uh, taken into the model, how they are imagined into the model, right? What mathematical concept is used behind the scene that we are going to see here. So let me explain you the rest of the things related to the MNIST. So when you load the data using the MNIST, then the data set is automatically downloaded and stored in some path like .keras and then datasets MNIST.npz, right? So something similar path, like it may be that you have some folder in your users, profiles folder. So in that user profiles folder, you can see something like wherever uh, uh, your Python has been installed. So that location may be used for installing all this. So this is the place, this is the path, like this is the final path, right? Which will be, suffixed with the previous path, whatever path you have in the beginning. So ultimately it will be suffixed with this path, okay, or equivalent to this path. So if this has been downloaded, then it will be taken from there only and it will be known as the cache of the images. But if it is not there in the cache, then it will be loaded again. Fresh loading will be done. Okay, so it has been already mentioned here. You can also use mnist.load data. Okay, if you want to load it, if you have the data already present from somewhere, like if you know that, yeah, I have this mnist.npz that I have taken and downloaded somewhere at some location at some path, then in that case, what you can do, you can call this function mnist.load data, and you can simply give the path like this. Path is equal to this path. Okay, so with this way, in this way, you can also download all the images. Not download. Basically, use the images, load the images into the cache from the local path. Okay. Now, but let us see the mathematics involved behind all the images, how the images are perceived, what mathematical concept is used. So the mathematical concept that is used here to manipulate the images, to understand the images, that is known as the matrix. You must have understood about the matrix in your college days, in your school days. But yeah, this very simple operation involved here, you will be able to understand it very easily. So suppose we have two training images. You have 60,000 images, but yeah, here you can understand two images for the sake of simplicity so that you can understand it quickly. So suppose we have two training images, which means the number of samples are two and there is one testing image. Okay. And each of the size 28 cross 28. Why we take 28 cross 28? Because all the images that have been taken into this library, which is MNIST, they are all of size 28 pixels cross 28 pixels. So height is 28 pixels, width is 28 pixels. So everything is width and height, both is 28 pixels only. So we are also taking it as 28 cross 28. So this will be the training matrix. Okay, so this will be a two-dimensional matrix of 28 cross 28, 28 rows and 28 columns. Okay, so you know that every image has certain, certain dark points, certain different colors. There are different shades of the different colors in an image. Okay, so here you can see there are different images. There are two images, right? So first image data has been taken here. This is the one. So these are 28 rows. So in the first row, you can see 28 records. They are the pixel values. Okay, 12 is the pixel value, which basically the color pixel value. Okay, you know that the color range, if you know about the programming and if you know about the colors, then you know that the color range it is identified from 0 to 255, right? RGB colors, red, green, and blue, all these are taken from the are their values are taken, their shades are taken between the value 0 to 255. So any value between 0 to 255 is representing a kind of shade, a kind of intensity of the color at that point. Okay, so here you can see like these are the different intensities, right? 12 is the intensity at first pixel, first row, first column. Then second row, second column, it's 30, it's 15. Then it's 33 at the 20th row and 28th, 20, and oh, sorry, first row and 28th column. Okay, so that is the way it has been arranged. So every value in the matrix, in every cell of the matrix, every value in that cell of the matrix is representing the intensity of some color of that image. Okay, so we are assuming that we just assuming that these are the pixel values, these are the color intensities with respect to the pixel values. Okay, so now again the same thing is applied to the test image. So you use the training image and you do the same thing through the test image. So in the test image as well, you have sample size 1. There is only one image and there are 28 cross 28 pixels again. So there is only one matrix of size 28 rows and 28 columns. Okay. So this is the way the image is represented. So every row and every column is representing the intensity of some kind of color in the image. Okay, so that is represented by the pixel value intensity, the color intensity for each of the pixels. Okay, so that is how the images are represented in the machine learning, or you can say in the computer language, in the computer programming. Okay, in the NumPy, we have already seen that we import the NumPy library to use the arrays. So here we are using the array. So x underscore train is equal to np.array, and then in the array you can have 28, you know, 28 cross 28 two-dimensional array. So this is the way you can have that array. Okay. Now come to the x underscore test is equal to np dot array. Here it is for the test one, x test. So here you can see all the details are there. Pixel value range is 0 to 255. This representation allows for efficient processing and manipulation of the images data using NumPy and various machine learning libraries. Okay. So how these values like 0 to 255, we have used the values, right? So we are not directly using these from 0 to 255. We, we just manipulate this data in the matrix uh, to have the values between 0 to 1 in some decimal value, right? So we divide every value, like every row and every column value divide by 255. So when you divide it by 255, then you get a particular value which is in between 0 to 1, right? So it is 0 when it is 0, it is 1 when it is 255, but anything between 0 to 255 will be less than 1 in the decimal value. Okay, so that we will see that how we do by reshaping the image data to do so, because if you do these things, then it becomes really easy for the machine learning models to work on these values, the decimal values, right? But on these integer values, it becomes really tough for them to work on, right? So the most efficient working of the Keras library that we are using, you must have seen the Keras library we have imported from the TensorFlow. So that library works efficiently only when the values are between 0 to 1, because the data gets normalized in that case. So we will see in the next video, in the coming videos. Okay, so here are the properties. X train shape is two rows or two images, sample size is 2, and the row and columns are 28 and 28. Okay, and the data type is unsigned int 8. Why 8 bytes? Because till 255, all the values can be accommodated between 0 to 8 0 to 8 bits. Okay, so pixel value range is 0 to 255. This representation allows for efficient processing and manipulation of image data using NumPy and various machine learning libraries. So here are the details. So rows and columns we have already discussed. Then comes the values. So each value represents the pixel intensity at that location. Pixel intensities range from 0 means black to 255, which means white. Then the values are typically 0 means black and 255 means white. Intermediate values are the grayscale values. So here is the example, like here it's like 12, 15 and 20. So row 1, column 1, which means value 12, it represents dark, very dark gray. And then row 2, column 2, which is value 30, it represents medium gray. And then row 3, column 3, it represents pixel intensity in 50, light gray, right? So these are just the examples, like what are the different values and what they represent. Okay, so in real life you will be able to see, so in really when you write the program, then you will be able to see that you will be able to see light gray and medium gray and very dark gray, all these things. Okay, apart from that, these values if you want to see whatever images that you are using for the training purpose, if you want to see that how those images look like, right? If you want to see them, then in that case, you can use this piece of code, right? But unfortunately, I cannot use this piece of code with this particular Visual Studio Code. I must like to use it using the, you know, Jupyter Lab. So I have Jupyter Lab installed. So in the next video, first of all, I will show you this thing, that how the images can be shown. Just like here in this program, you can see, we will see the 0th image after training or before training. We will be able to see that what is the image at the 0th index, which means the very first image in the training set. How does it look like? What is the image there? That thing we will be able to plot using the matplotlib.py plot, and we can show it in the form of a graph, or you can say in the form of a matrix. So that we will see like how that image looks like. Okay. So I hope you must have understood the graphical representation of the image or matrix representation of the image in the machine learning. So in the next video, we will see the visual representation, and then we will see the other mathematical concepts, and basically this thing involved there, like pre-processing the data, why we are reshaping, and what happens after reshaping, right? So these things we are going to discuss in the next video. So I hope you must have enjoyed this video and you are getting it, getting the concepts easily. So in the next video, we will be able to see that how you can represent the data, you can show the image, and how and why we pre-process the data. So with this, I would like to say have a nice day and bye bye. Thank you.